Hello, I'm going to show you how to do the roller coaster energy calculations. So I've changed up the numbers so that I can just run through it, and then what you learn here you can apply to your own assignment. So here's the situation. We're starting off with a cart that went up this hill and it's currently going 2 meters per second, and it's going to travel down and then go back up and then over the second loop. Our first task is to calculate the potential energy at point A. So potential energy is calculated PE equals mgh, and that's when we're dealing with gravitational potential energy. M is 1 kilogram, and I'm just going to leave units out so that I can fit everything in one box. So 1 kilogram, that's the M, G 9.81 times the height, and our height is 6 meters. Okay, so 9.81 times 6 is equal to 58.86. And for this assignment, like for this demonstration, I'm just going to round to 59. And our unit is joules. Alright, so now the kinetic energy. Kinetic energy is just the energy that that object has, or that cart has, due to its motion, and it's currently going 2 meters per second. And it has a mass of 1 kilogram. So both of those are going to be factors in its kinetic energy. So Ke equals 1/2 m times the velocity squared. So we have 1/2 times 1 kilogram times 2 meters per second squared. So I guess I don't have to type this in my calculator, but just for demonstration, so we have 0.5 times 2 squared, and we get 2. Alright, so next is our total energy. So the total energy is just going to be the combined total of potential and kinetic energy. So I'm going to write total energy is just TE equals potential energy plus kinetic energy. So that will just be (61 joules). Alright, so now the fact that we have 61 joules of total energy is important, and we're going to have to remember that throughout this whole assignment. So let's go through some of the easiest ones first. So potential energy at point B. We have all of the information that we need. We know that the mass is still going to be 1 kilogram, and we're given the height, and we know the acceleration due to gravity, or g, is going to remain constant. So we could easily get the potential energy for all of these. So 1 times 9.81 times, I already forgot, 3 is the height. So 9.81 times 3, 29.43. I'm rounding a lot right now. I'm just going to make it 29. All right, and let's do the next one too. So potential energy at point C. Ooh, super easy. The height is 0, and so we're not going to have any potential energy at point C. So the mass is 1 times 9.81 times 0 is just going to be 0. And let me put the units there. 0 joules. Okay, so now let's look at the kinetic energy. So the key thing that you need to remember, as I was saying, like the 61 joules, the fact that the total energy is always going to be equal to the potential plus the kinetic energy is how we're going to solve this. So if we already know the potential energy and we need to figure out the kinetic energy, it's just going to be a subtraction problem. So total energy is equal to PE plus KE. And if we rearrange that to solve for kinetic energy, we just have to subtract potential energy on both sides. And just to make this cleaner, I'm going to erase that and rewrite it. There we go. So it's the total energy minus the potential energy is equal to kinetic. So now, I don't know why I'm now putting units there. I need to relax. Okay. Minus 29. So the total energy minus potential energy at that point. $32. Now we'll give it some units. Nice. So now we have the kinetic energy. So the last thing we have to do is figure out how fast the cart is going at point B. So the velocity. Now, we do know that velocity and kinetic energy are related. So KE equals 1/2 mv squared. And so let's look at the things that we know. We know the kinetic energy now. We know the mass. And so our only unknown is the velocity. If we only have one unknown, then we're ready to solve. So 32 joules for kinetic energy is equal to 1/2 times the mass times the velocity squared. One half times 1 is just 1/2. So I'm going to divide by 1/2 on both sides. So 32 divided by 0.5 is equal to 64. So don't just cut 32 in half. We're dividing it by 1/2, which is the same thing as multiplying 32 by 2. So we get 64 is equal to v squared. And And the last step to solve for v would be to take the square root. So the velocity is equal to the square root of 64. And I'm kind of running out of room, but I'm sure you know square root of 64 is just 8. All right, so now I'll do one more line of this grid and then I think you guys will be set. So this one, super easy one, because if there's 0 joules of potential energy, that means all of the energy is in the form of kinetic energy at point C. And so I don't even need to do any calculation for this. I can just say the kinetic energy is equal to the total energy, therefore it is 61 joules. And we're done with that one. Now for the velocity, same thing as before, let's do one more practice. So we have 61 joules is equal to 1/2 times 1 times v squared. So we're gonna divide by 1/2 on both sides, and I'm gonna probably gonna run out of room again. So I'm kind of shortening the steps, at least what I write, just so I have room. So now last step, gotta take the square root on both sides, so v is equal to the square root of 122. And it's around 11. And our units here are meters per second. So this isn't a perfect way to check your work, but you can at least kind of verify. So at point C, that should be when our cart is moving the very fastest. And that's because all of its energy got converted to kinetic energy. So a way to kind of verify, I mean, it's not perfect, but the fact that this value is larger than that value is a good sign, because if it was going slower than 8 meters per second, then it wouldn't make sense, because this should be the point at which the cart is moving the fastest. And you follow the same idea all the way through, and that's how you do the assignment.